Hello, ladies and gentlemen. My name is Chris Njoku. Today, we're looking at statistical analysis as a beginner using Microsoft Excel. We are going to start with simple regression analysis. Simple regression analysis. Now, oh, let me explain what simple regression analysis can do for you. Look at this data very well. We have hours and then score. Let's assume that you want to understand the relationship between the number of hours the student studies and the score in an examination using regression analysis. This is very possible. What you need to do is to put the data in order, and then you run a simple regression analysis on the data. The outcome will determine if you'll be able to predict a student's score using the hours the student studied. So let's get down to business. This is the data before us, and then we have like 20 points of the data from A2 to A21. Mind you, this very first row, hours and score, are labels to the data. So first thing we'll do here is to highlight the data. Highlight the entire data, including the label, and then click on your Insert tab and go to Charts and click on Scatter Chart, this very first one. So this is it. This chart is showing you that there's a relationship between the hours the student study and also the scores that they obtain. So you can see on the y-axis we have the scores, and on the x-axis we have the hours studied. Now, for those of us that are not grounded in statistics, I want to explain something about this data to you. These two columns, one of them is referred to as an independent variable, while the other is known as a dependent variable. Now let me type it out. Independent variable, and then dependent variable. Let me explain the one that is dependent and the one that is independent. The independent variable, just as the name suggests, does not depend on any other variable. In this case, from the two columns, the independent variable here is the hours, The hours does not depend on the score. Rather, it is the score that is dependent on the hours studied. So the independent variable here is hour. And then the dependent variable is score. So by time we go on and then you hear me mention dependent and independent variable, just understand where I'm coming from and what the statement meant. We move forward. Next thing we are going to do here is to probably look at the simple regression analysis proper. What we have been doing is to lay the foundation that will take us to where we are going. Now, to perform simple regression analysis on MS Excel, you need the data analysis tool pack. If it has not been installed on your system, you install it. However, if it has been installed, you see it there when you click on your data tab. You look to your extreme right top, you see data analysis. It has been installed in this case. But if yours has not been installed, this is how you do it. You click on the File tab, scroll down to Options, you click on Options, you click on Add-ins, and then ensure that on this Manage, you're seeing Excel Add-ins, and then you click on Go. As you can see Analysis to Pack. So if it's checked, just know that it has already been installed. If it has not been installed, you just check it here and then you click OK. So you see it visible there. You can see this is it. So let's move forward. In order to perform the simple linear regression analysis, in order to perform a simple linear regression analysis, we highlight the data just like we've done before, and then we click on the data tab and scroll to the data analysis command, and then we click on regression. That is our interest here. You can see there are so many analyses that can happen here, but our interest is regression. So it's on regression. We click OK. Now, the next thing we are to do is the input Y and S range. If you're performing it for the first time, you see this box is empty. So I'm going to delete everything there and then do it afresh for you to understand. So input Y range. What is your Y range? Your Y range is the dependent variable. Understand this very well. Your Y range is your dependent variable, which is your score. I think I should type it out here. Okay, let me go select the data. Your Y range is your dependent variable. I repeat, your y range is your dependent variable. And so to get your dependent variable, which happens to be our score, you click on this and then you go and highlight only the y range. So this is our y range. If you're done, you click on this. You can see it has been registered. And then your S range, which is your R's, your independent variable. You click and then go and highlight it as well. So when you're done, you click on this. And so you check this. If it's not checked, you check it. The reason you're checking it is you want your cell to recognize that you have labels. So these are the label. However, if you highlight only the data itself without highlighting the labels, you uncheck this for it to be open. So Excel will realize that you don't have labels in the data range you highlighted. So try to understand that if you highlighted your labels along, you have to check it. So that is that. And now we move forward. The next thing is for your output options. If you want your output to be on this very workbook, now this worksheet, this work page now, you check your output range and then you just pick a place to drop it. You can just do this and then when they ask you for this, you click on this. When you do, you are expected to just drop your cursor where you expect the output to be displayed, like from F down this way. So your output might contain a whole lot of this, can contain this circle I made with my cursor. So now I filled a lot of data here. I want my output to be on another sheet. You can see we have two sheets here. I want my output to be on another sheet. So I am not going to select anything there. So I'm closing this. I want my output to be on a new worksheet. So I click on this. Now I've clicked on this, Excel is going to drop it for me on a new worksheet. And so as beginners, you might not want much of this because if you do, they might get you confused. So what you just do, you leave them. These are meant for um, people that have advanced skills of this because there are so many explanations attached to this. But if I bring it in for you now, I might just get you confused. So you have to move according to your pace so that you understand better. So I click OK. Now you can see that Excel has created another sheet. We had two here before. So this is the sheet Excel has created, and then your output has been displayed here. So this is it. I just want to expand this a little bit so that you see everything. You can see how I'm expanding my columns. So for you to expand, you come to the boundary line and then you drop your cursor there. It changes to this two cross and then you hold down and drag to whichever direction. So now we move forward. This is the result. The output of the regression statistics is here. However, this requires explanation. There are so many details here, but as a beginner, there are some details that you have to start with. If you have good understanding of those details, you can move into other details as your knowledge advances. One of those details you should start with is the R square. Let's see if I can color it. Just select, go to the home tab and choose a color here. So just see what I did. So this is it. The first thing there is the R squared. Now, let me explain the R squared to you. The R squared is known as the coefficient of determination. Let me type it here, close to it, so I understand what it means. Coefficient of determination. Now, the coefficient of determination, what does it stand for? The coefficient of determination is a proportion of the variance in the dependent variable. Now, let me try to break it down more. We talked about dependent and independent variable. If you remember very well, I said your dependent variable is that variable that does not depend on any other variable. It is just on its own. And in this case, I said your R is your independent variable. It does not depend on anyone. Your R's does not depend on score. Rather, it is your score that depends on the hours of study. So that is why your R's is taking the place of independent variable. And then your score is taking dependent variable. So now we move back to the data itself to explain the coefficient of determination. Your coefficient of determination is the proportion of the variance in the dependent variable. The proportion of the variance, the proportion of how your dependent variable, which is the score, varies in the data. Let me repeat again so that as you're watching this video, you'll be able to grab this very well. The coefficient of determination, also known as the R square, is the proportion of the dependent variable, which is the score, that varies, that can be explained by the independent variable. What does that mean again in simpler terms? We have hours, 1 hour study, and then we have score 76, 2 hour 78, 2 hour 85. This is how the data looks like. And so the coefficient of determination is talking about the percentage of the data. Let's say out of 100% of the data, how many percent of the data can you use one? Can you use the dependent variable to explain the independent variable? If you watch this over and over and maybe try to get my explanation, it will do you a whole lot of good. So the coefficient of determination is the variance of the dependent variable, which is the score, that can be explained by the independent variable. Like I said before, your independent variable helps you to explain the dependent variable. Your independent variable is hour. Your hours help you now to explain the scores of exam, because you have to study for hours, and then the consequence of your study is your performance in the exam. If you study very well, you spend so many hours, of course, those of us that are students, if you tell yourself the truth, the more you study, the more your chances of having higher grade. That is just how it is. We understand that, but we are trying to explain it using statistics. And if you watch this video to the end, you are going to understand everything plain. For those of us that want to go into data analytics, what I'm trying to explain to you now is data analytics at a beginner level. If you follow me along to the end, you are going to see that data analytics that you are hearing. Not data analysis, the data analytics that you are hearing. Data analytics means predicting using the information you have at hand. So that is what data analytics is all about. So we move forward. The coefficient of determination here is the proportion or the variance in the dependent variable that can be explained by the independent variable. In this case, we are having 0.72. That 0.72 is like 72%. That is what it stands for. So it's telling you that 72.7% of the dependent variable is explained by the independent variable. That is what that statement stands for. So we move forward. The next that you should understand now is the standard error. Okay, this is the standard error. So the standard error is like the average distance that the observed value fall from the regression line. Let me explain this by going back to the sheet 1. Okay, this is the graph that was plotted, the relationship between this and this. Quite understandable. Those of us that did statistics, you know that you can bring out a trend line from this. So watch me do that. I right click a point and then add trend line. So you can see how the trend line looks like. You can see it now. This is a straight trend line, like moving forward, like the relationship is like a positive relationship. That is to say, the more hours you spend reading, the higher your score can be. Let's take this as an example. Let me explain from this is 1 hour study, and then you see where the point is, take it down to the score. You see that it falls between 60 and 80, right? Okay, see this person now that studied 4 hours. Draw your line to this place and see. The least you will get on this line is this point. If you take this point now, trace it down to the y-axis, you see that it falls on 80 something, let's say 82 or so. That's to tell you that the score of someone that studied 4 hours is higher than the score of someone that studied 1 hour on the average. So that is an established relationship already, right? So let's go back to sheet 4. So the standard error is telling you the maximum height, the average distance that can be observed, like an error, like you cannot see it falling below 5.28 as you are moving. It's a straight line, yes, but sometimes you observe that someone will still have a score lower than the previous one, going by the amount of hours studied. Let me show you what I mean by that. Okay. Let's see this now. This person studied 2 hours and got 78. Look at another 2 hours and the person got 85. You can see the difference between this and this, right? Which is about 8 or 7 or about 7. Look at another 2. The person got 72. You can see the distance also. So from this one to this, you can see the gap. From this to this, you can see the gap. These are people that studied for 2 hours. See another person that studied for 2 hours, person got 88. So when you observe one person, the first person that studied for 2 hours and got 78, you saw another person that studied for 2 hours and got 85. This is 2 hours. Say the first person got 78. So let's say this is 78. And then the next person got 85. You can see the distance jump up, right? And then another person studied for 2 hours and got 72, which means it jumped down again. So that distance is the standard error. I believe I've been able to break it down. That distance, the falling down and the going up, is the standard error averagely, because at the end of this, the falling down will be calculated. The one that is up, the one that is down, just add all together, and then you do average analysis. And then Excel is telling you that averagely the distance is 5.28. So that is your standard error. So you can type it here. I'm just doing that again, even though it has been typed here, but let me just drop it here. So standard error is 5.28. So we move forward. The next thing we are going to look at is the coefficient. Wow. The coefficient is what will give you an idea of how to predict using data. You see, this is it here. Coefficient. Your coefficient is made up of the intercept and then the hours that you are going to use in your prediction. So you can easily write out an equation that is known as an estimated regression equation, because what you are trying to obtain here is exam score prediction. You want to be able to predict exam score based on the hours that students studied. I just hope that someone will relax and listen, watch this video to be able to grab it. For those that have background of statistics, mathematics, you can understand it easily. But those that are just coming into it, they have interest in data analysis, data analytics, and the rest, and this is statistical analysis. They might find it very funny because what I'm saying now might be like jargons to some persons, but if you take your time and understand it, you are going to enjoy using it very well in even your business and a whole lot of things. You can use it to predict a lot in your business. So moving forward, this is what your coefficient looks like. Let me type it out below. Let's see coefficients. So what you are trying to understand from the beginning is the exam score. So moving forward, your exam score is equals to your intercept plus hours. I want to type in calculator. Okay. Plus R. Plus R. I'm still moving forward. Let me drop my cursor here. Multiplied by multiplied by the number of hours that you want to probably predict. Let's say you want to use this information to now predict what a student that studied for 3 hours in an exam should averagely score, or a student that studied for 5 hours should averagely score. So in bracket, you can put the hour. Let's say we want to start with 0 hour. 0 hour. So look at this data. Writing your coefficient now. Let's say you want to model, predict the exam score of a student that studied for 0 hour, maybe less than an hour. So what should the student score? So let's do simple mathematics now, and then maybe to help you to understand better. So exam score here now will be equals to intercept. This intercept, you can see it here, intercept 67.16. So you say 67.16 plus hour here on the prediction model is 5.25. So we'll say 5.25 multiply by, we said we want to start with a student that studied less than 1 hour. So let's say 0 hour. So we say multiply by 0. We'll press our enter key. This is what it gave us. It gave us 67.16. That is for a student that studied for, let me see, for, sorry, for a student that studied for 1 hour. For 1 hour. So this is it. Now we want to go back and try for a student that studied for 3 hours using the coefficient equation that we have now. So we say equals, what's our intercept? Our intercept is 67.16, 67.16 plus our 5.25, 5.25 multiply by, we said multiply by 3 hours. We said we'll try 3 hours. So hit our enter key. Look at the exam score of that student, 82.91. See, for a student that studied for 3 hours. Change it to 3 hours. Can you see the difference? This is what we call prediction. You can see that a student that studied for 3 hours is expected to score at least 82.91. Let's look at a student that studied for 4 hours. You say equals, our intercept is what? 67.16 plus 5.25, sorry, 5.25 multiply by, we said 4 hours. So 4. So we hit our enter key. Look at what it gave us, 88.16, higher than the student that studied for 3 hours. So let's try this final one. Let's try for a student that studied for 5 hours. So say equals, our intercept is what? 67.16 plus 5.25 multiplied by 5 hours. Enter. So a student that studied for 5 hours is expected to score at least 93.41 as the score. I'm sure you are seeing how interesting data analytics can be. I'm very happy for anyone watching this video. I wish I had someone that could teach me this way. I didn't, so I had to learn a lot myself before I was able to understand this. So this is just what a simple linear regression analysis can do for you. So you have learned how to do it using the data. You have also learned how to interpret it and also how to use it to make prediction. This is the very last thing I did here. This coefficient is meant to help you predict. This data you're seeing here now, coefficient, the intercept and the hour. This is the coefficient. So the intercept and then the hour make up the coefficient. And so the coefficient can help you to make prediction. So I don't want to go deep into this because there are a whole lot that are here. But maybe subsequently I will be making a video because p-value is another aspect of statistical analysis which you understand as you go deeper, and then how to interpret it is also very, very vital, especially those in statistics, in environmental analysis, those in financial modeling. A whole lot you will need such as you move deeper. I do hope I've been able to educate someone here. Thank you very much for making our time to see this video. Before we move further, let me tell you that I am open for mentorship, and then you can also see some of my free videos on my YouTube channels. So let me click on this. This is me. If you need special Excel mentorship, you can reach me out. This is my WhatsApp. And these are the areas I can help you become a guru. Excel data analysis, VLOOKUP and pivot table, beginner to advanced coaching, Power BI, statistical analysis, which I have just shown you how to start, big data cleaning and analysis, data visualization techniques from beginning to advanced level. I do that. And so this is my YouTube channel. I'm known as Simplifier. When you go to YouTube, you type Simplifier, a whole lot will be suggested to you. You will see my face, and then you can subscribe and watch my videos. Turn on the notification. There are a whole lot of videos there to watch, and more will be uploaded anytime soon. And so when you turn on the notification bell, you'll be notified each time I make a video. Thank you very much and goodbye.